Hello, good morning everybody. So today we are going to study about super elevation. As we have already studied about the different forces overturning effect as well as lateral skidding that is occurring on the vehicle when it is moving on the curved road or a horizontal curve. So overturning effect will be taking place and lateral skidding will be taking place. So in this paper or in this video, we are going to study about the super elevation. Super elevation. Let's first understand what is super elevation. In order to counteract the effect of centrifugal force and to prevent vehicle from overturning when traversing on a curve, outer edge is raised with respect to inner edge and hence providing transverse slope throughout the length of the curve. When a vehicle is traversing on a horizontal curve, this is a horizontal curve, right? When the vehicle is traversing on a horizontal curve, the outer edge of the road is raised by some value or some height is given to the outer edge, which is in respect to the inner edge. This height would be the super elevation that is provided on the road, and this would be on this direction. The This would be the higher height, and this would be the lower height, right? So this transverse slope of two pavement surface is known as super elevation. It is also known as cant, or it is also known as banking. So let's analyze this diagram. Here, the road is represented by this shaded portion. This represents the road. There are different forces that are occurring on this road, since the road is on this side and it will have a radius on this side. So will the r value, and a centrifugal force of pc is occurring on the vehicle. The vehicle is moving in the longitudinal direction. A What do you call it, a centrifugal force of pc is acting on the vehicle. Next is the weight of the vehicle is represented by w, and the angle by which the super elevation has been provided is theta. So this theta and this theta would be same. Let me mark it in the diagram as well. This would also be theta and this value would also be theta. So the PC will have two components, which is one is PC cos theta and one would be acting perpendicular to the road surface, which would be PC sin theta. W will also be differentiated into two different components. One would be W cos theta and another one would be W sin theta. The one closer to the angle theta would be W cos theta, and one opposite from that would be W sin theta. One force and one another force would be acting on the vehicle is friction. So friction would be equal to basically the perpendicular component that is acting upon the vehicle, W cos theta as well as P sin theta, when it is multiplied by F, that is friction coefficient, will get the frictional force, right? So in this diagram, one thing to be noted is summation of fx should be 0 if it needs to be in what do you call it, equilibrium. It The equation of summation of fx equal to 0 needs to be justified. So for w sin theta plus friction would be equal to pc cos theta. The one uh, the one force that is pushing the vehicle outside or in the outside direction, it would be equal to w sin theta as well as friction. If it is not equal, the vehicle will start moving in one direction or the other, right? So let's first of all define this needs to be defined. It is the height by which outer edge is raised. So the outer edge is raised by a value of capital E, which would be equal to this. B represents the width of the pavement. The theta represents the angle by which the pavement has been rotated, and the height is given by B dot tan theta. If we bifurcate it in simple terms, tan theta would be equal to E upon B, and E would be equal to B tan theta. right? So that is it. Next, uh, B represents the width of the pavement. Next, we need to understand what are the forces acting on the vehicle. The forces acting on the vehicle are, first is the weight of the vehicle as represented by W. It is acting vertically downwards. It is not acting perpendicular to the surface of pavement. It is acting vertically downwards. This needs to be noted down. Next is centrifugal force. It is acting horizontally outwards, and it would be opposite from the it would be opposite towards the radius of the curve. If radius of the pavement or the horizontal curve is on this side, the PC would be acting on this side, right? Here also PC is represented in horizontally outwards direction. Next, frictional force. It is the horizontally inwards force that is acting parallel to the surface of pavement. If this is what you understand, that friction should be in horizontal direction, it would always be in the direction of the pavement surface, because friction is a function of pavement surface. uh, Sorry, it is always parallel to the pavement surface. It is a function of material type, and uh, friction material type defines the friction coefficient, and the mm, what do you call it, resultant or neutral force is the normal force. Normal force is the opposite to the what is being exerted on the plane surface, right? So for equilibrium condition, summation of fx should be 0. So w sine theta plus f would be equal to pc cos theta. Here also we have written that only. So this would be taken as equation 1. Next, r1 plus r2 would be equal to w cos theta plus p sine theta. R1 and R2 is the reaction force that is being exerted on the two tires, particularly due to the vertically downwards force acting, that is W cos theta as well as P sin theta. So R1 plus R2 would be equal to W cos theta plus P sin theta. From solving 1 and 2 equation, we'll get PC cos theta is equal to W sin theta plus F W cos theta plus PC sin theta. We'll put the similar terms on one side. So the one with PC and PC would be kept on one side. It will come out to be cos theta minus F sin theta, and W is multiplied by sin theta plus F cos theta. Now PC upon W can be, this can be taken down, and it will come out to be PC upon W, and sin theta plus F cos theta is divided by cos theta minus F sin theta. One thing to be noted down is when theta is small, sin theta is approximately equal to cos theta. We can also have a look at this in the calculator as well. Let us assume that sine of 1 is something. It is to be divided by tan of 1. That is approximately equal to 0.99998, which can be taken as approximately equal to 1. So sine theta upon tan theta will approximately, sine theta when divided by tan theta of a very small value, although this value is near about to 0.07% is the maximum value that it can have. So according to that, sine theta is equal to tan theta, and for cos theta is equal to 1. Now let us assume that tan theta is equal to E, so that we have easy calculations available, and it can be given a name of E. So PC upon W is equal to E plus F, 1 minus EF. Here this term has to be reduced because this is a equation that is unsolvable due to complexity. So for one thing, we need to understand that maximum value of E that it can have is 10%, and generally it is taken as 0.07, and minimum value of F would be 0.10, and normally it is taken as 0.15. So 1 minus EF approximately comes out to be 1, which can also be referred to in the calculator as well. You can calculate for these values. It will approximately come out to be 1. So PC upon W is equal to E plus F. Next, PC, as we know that PC is nothing but mv square upon r, right? It is the centrifugal force that is acting on the vehicle. So this has been put here, and 1 upon W is kept as it is. So M is also converted to W upon G. Mass is equal to weight upon center of, sorry, acceleration due to gravity. So WW will cancel out, and this will come out to be E plus F is equal to V square upon GR. Here V is in what term? V is in meter per second, right? If we convert meter per second to kilometer per hour, the equation of the super elevation comes out to be E plus F is equal to V square upon 127 R. Here R is in meter and velocity in kilometer per hour. This is done so that whenever the question is given, the speed is given in kilometer per hour, we don't have to convert it, right? And R is also given in meter. So some things that we need to understand and note down about this is maximum value of E that it can have is 0.07. It is it is exactly equal to 7% of super elevation. If E is equal to 0.07 is not satisfying the criteria, E is fixed to 0.0707 and radius is increased. There could be some cases where super elevation is coming out to be greater than 0.07, and that is not allowable as per IRC. So what we need to do is we need to increase the radius of the curve. Since E and R are indirectly proportional, if we increase the R and we fix the value of E to 0.07, we'll find the corresponding R required for that value of 7% value of super elevation. If radius can also not be increased, speed limit is implemented and is calculated as below. If there is a case that due to geometric restrictions it is not possible to reduce or increase the radius as well, and E has to be provided at 0.07%, and R can also not be increased, we need to implement the V allowable, and that is the allowable speed that is possible on the horizontal curve needs to be specified and the speed be restricted to that value only. So to calculate that value, what we'll have is E plus F plus is equal to V square upon 127 R. E will be fixed to 0.07, R is fixed to whatever value is given in the question, and VA, the allowable speed for 0.07% of super elevation, and for that particular R, we can find out the allowable speed, right? That is this. And next, we'll look at this question. Okay. Radius of horizontal curve is 110 meter. Design speed is 60 kilometer per hour, and F is this. Super elevation. Calculate super elevation required if the full lateral friction is assumed to develop. So we'll approach this question as R is given as 110 meter, velocity is given as 60 kmph, and F is equal to 0.15. So super elevation can be calculated as E plus F is equal to V square upon 127 R, right? Which will be equal to E is to be find out, and V square is 60 square upon 127 multiplied by the value of R is 110 and minus 0.15, right? So after calculating, let us see what is the value of E. Sixty multiplied by 60 is to be divided by 127 is to be divided by 110. That value would be this minus 0.15. The value is coming out to be 0.1076. 0.10769. Since only super elevation has been asked, this is what the value will look like, right? When we need to design the super elevation, the procedure is different, and that we'll discuss in uh, most probably in next class, right? So next is the calculate value of lateral friction needed if no E is provided. If for this would be on part A, for part B, we need to calculate the lateral friction if no E is provided. So E is equal to 0, V is equal to 60 kmph, and F needs to be calculated. What else is given? R is equal to 110 meters. So E plus F is equal to V square upon 127. R is equal to 0. F needs to be calculated, and V is 60 square upon 127 multiplied by 110, right? So let us calculate this. 60 multiplied by 60 is equal to, divided by 127, divided by the friction that is generated, or you can say the lateral friction will have a value of 0.25769. This is the lateral friction that needs to be developed. And since in the previous lectures we have discussed that the value of lateral friction that is available for uh, curves is limited to 0.015, although more friction is developed or can be developed, but for safety reasons the maximum value of F allowed on a horizontal curve is limited to 0.15. Hence the friction more than that is not taken. Since this question does not ask about anything about those things, so uh, this has only asked the value of lateral friction that is needed. So we'll not discuss anything else in this question. So we need to design the super elevation, but that will be in the next lecture. Okay, thank you for this class. As usual, please like, comment, and subscribe to get the regular updates. And if you need some topic to be explained clearly, you can share those topics in the Telegram group. I'll share the Telegram group link in the description as well. Okay, thank you. Have a good day.